Hello everyone. We have a question on thermal expansivity here. And the question says a rectangular piece of iron 4 centimeter by 3 centimeter at 20 degrees centigrade is heated until its temperature increases by 100 degrees centigrade. Calculate the new area of the metal. Linear expansivity of iron is equal to 1.2 times 10 raised to the power minus 5. This is a WAEC question, but there's a discrepancy in this question. I just noticed. It says the rectangular piece of iron is at 20 degrees centigrade and it's heated until its temperature increases by 100 degrees centigrade. The word here is supposed to be to 100 degrees centigrade and not by 100 degrees centigrade. Sorry. Okay, to 100 degrees centigrade. Calculate the new area of the metal. First of all, we know that when it comes to thermal expansivity, it's the rate at which metals expand when heated. Okay, so now for this particular question, now we are told to calculate the new area. We cannot solve this question without bringing out the formula for area expansivity, because we are talking about area now. We call it area expansivity or superficial expansivity. Okay, let's go now. Solution. What is a superficial expansivity? Superficial expansivity is just simply the increase in area per unit area per degree rise in temperature. Okay, moving on. The formula, the letter at which we use to identify area expansivity is known as beta. And beta is equals to increase in area, which is delta A, per unit area, that means the initial area, per degree rise in temperature, that means change in temperature, we call it delta theta. This is the same thing now. They say calculate the new area. So this is the same thing. Change in area is the new area minus the initial area, all divided by the initial area times final temperature minus initial temperature. So this is the formula we are going to use in solving this. But you will notice in the question that what was given was linear expansivity of ion and not the area expansivity of ion. But there's a relationship that connects linear expansivity and superficial expansivity. And that relationship is this. Linear expansivity is equals to 2 times, sorry, area expansivity, beta, is equals to 2 times the linear expansivity. 2 times the linear expansivity. So what that means is that since the linear expansivity of ion is 1.2 times 10 raised to the power minus 5, therefore the area expansivity of ion will be 2 multiplied by 1.2 times 10 raised to the power minus 5. And that will give us 2.4 times 10 raised to the power minus 5 per Kelvin. Now, since we have gotten the superficial expansivity of iron, we can easily solve this question. And the formula we put on the board here was beta is equals to new area minus initial area divided by the initial area times the change in temperature. Okay, now in solving this question, I would love to put out the value of each of these so that it will be easy to solve. So we've already gotten the value of the superficial expansivity. So now what will be A2? A2 is what we are looking for. The new area is what we are looking for. What's the initial area? A1. It was not given, but you will notice that the length and the breadth of the iron was given. And what's the area of a rectangle? They told us that it's a rectangular piece. It's simply length times breadth. So that means the initial area will be equals to 3 times 4, which will give me 12 centimeters squared. So moving on, I've gotten the initial area. The final temperature is 100 degrees centigrade and the initial temperature is 20 degrees centigrade. So I'll have that theta 2 is equals to 100 degrees centigrade and theta 1 is equals to 20 degrees centigrade. So having put down all my data down, I can plug them into the formula to solve. So that means beta, which is 2.4 times 10 raised to the power minus 5, beta will be 2.4 times 10 raised to power minus 5, which is the superficial expansivity, is equal to A2 is what we are looking for, minus A1. We got that as 12 divided by A1, which is 12, multiplied by theta 2 minus theta 100 minus 20. So this will give me 2.4 times 10 raised to power minus 5 is equals to A2 minus 12 all over 12 times 100 minus 20 will give us 80. This is the same thing as over 1, right? Mathematics students, you know that from here I just need to cross and multiply. A2 minus 12 will multiply 1, and 2.4 times 10 raised to power minus 5 will multiply this. So moving on, I'll be having A2 minus 12 is equals to 2.4 times 10 raised to power minus 5 times 12 times 80. So I have that A2 minus 12 will be equals to, let's use our calculator to multiply. I'll be having 2.4 times 10 raised to power minus 5 multiplied by 12 and multiplied by 80. So I'll be having 2.304 times 10 raised to power minus 2, or I'll just leave it the way it is in the calculator, 0.02304, right? So now making A2 the subject of the formula, it means that this minus 12 will cross over here and the sign will change to positive. So our final area would be equals to 12 plus 0.02304, and adding that, our new area will be equals to 12.02304 centimeter squared. So centimeter squared because it was area, right? So that's the solution to this easy question.